My name is Navaniswaran. I'm a master student from the National University of Malaysia, and I'm today presenting my idea, which is the role of Fei Yang Sun in prebiotic chemistry, a chemical perspective on prebiotic polymerization. Here, in Origin of Life, here we can see how life may have originated in our planet. First, the creation of habitable world will result in synthesis or result in the synthesis of prebiotic molecules as well as polymers or vesicles. And these vesicle-like structures can give rise to the protocells and become a LUCA, which the last universal common ancestor.
Sorry, can I interrupt you?
Yeah.
Because we can see we cannot see your presentation mode. We can see the windows of your presentation on the left side. So please try to share a screen once more, but use the presenting whole screen, the entire screen instead of one window.
Oh, okay.
It should work.
Sure. Let me stop sharing.
Yeah, perfect. We can see the presentation, but we can hear you. Oh, yeah, I can hear you right now.
All right, can you see? Oh,
everything's fine.
Let me show you. Wait, let me see. Stop sharing. Should I share the window?
That's fine.
Is that okay?
When you were sharing a whole screen, we saw your presentation. Right now, you're sharing only a window.
Yeah.
And you cannot see a presentation mode, or you didn't set it on. Yeah.
Did I see? Can you see? It doesn't come out, right?
Yeah, not really. Yeah, you need to share a whole screen.
Oh, okay. Wait. Old screen, stop sharing. The screen is coming up.
Yeah, and you can try to go to the presentation mode.
Yeah.
Yeah, perfect.
Okay, can you see that? Okay.
Yeah.
Okay, I continue from the LUCA. From this LUCA, it can become diversified to become a life form, like bacteria and eukaryote and whatsoever. So our team in UKM are more focusing on the prebiotic synthesis as well as the polymerization. Okay, here we can see another experiment shows a simple dehydration, simple wet and dry cycle shows formation of polyester gel from alpha hydroxylic acid. And the unique of this gel is that when we diluted in the aqueous acetyl nitrate solution and water, it become a micro droplet. This micro droplet, the unique of this micro droplet is that it can incorporate other compound within into them, just as like the dye or RNA or DNA. So that over here we can see that this cycle is a setup of mimicking what happened in the geothermal. So over here we can see there is a lightning discharge, also heat generated from the volcano eruption, geothermal as well as hydrothermal vent, and also the radiation from the early sun are believed to be the source of energy that drive these prebiotic chemistries. So my research are more focused on this early sun, where the sun is a star at the center of solar system, provide heat and light to our solar system, and is essential to all life in our planet. So, but the sun is totally different when compared to current sun, which is called as a fade young sun, because this fade young sun first introduced by Carl Sagan and his colleague George Mullen in 1972. His theory stated that the sun was 30% less brighter in 4.6 billion years ago. So, due to that, the radiation emitted from the fade young sun direct toward to the early Earth was insufficient or not enough to prevent the Earth average temperature from dropping below the freezing point of water. So, due to that, the early Earth could expected to be completely frozen at negative 18 degrees Celsius, as shown in the diagram. Here, a graph representing the luminosity of the sun versus the geological timescale as well as the surface temperature of the Earth. The x-axis showing the solar luminosity as well as the temperature, whereby the x-axis showing the timescale and the y-axis showing the solar luminosity as well as temperature. And then the dotted line is the freezing point of water, where we believe that in 3.5 to 4 billion years ago, the sun was less dimmer, so that it should our Earth completely frozen. But geological evidence contradicting this, because liquid water and sign of life already existing 3.5 to 4 billion years ago. This suggests that our early Earth temperature was above the freezing point of water. So my research are more focusing on the transition energy from the fade young sun that can initiate the chemical reaction, because I believe that the broad radiation of the fade young sun can initiate the chemical reaction, could allow the origin of life to occur. Here, simple diagram illustrate electromagnetic spectrum, where we can see the broadband of the spectrum, including the UV visible light and also the infrared. We believe in current condition, this is a current condition of the Earth, where presence of ozone layer will filtrate some of the harmful UV radiation to reaching toward the Earth. But when we compare to the early Earth, it could be totally different, where absence of the ozone layer will allow all these harmful UV radiation to reach on this surface that could initiate some of this chemical prebiotic chemistry. So recent research shows that UV radiation from the sun play a significant role in facilitating the process of prebiotic chemistry, just as synthesis of ribosugar as well as nucleobases. So another experiment conducted in 2021 using the fade young sun as a simulator to create hydrogen cyanide as well as nucleobases. And this graph representing the spectrum irradiation of the current sun compared to the fade young sun, which they are used as a K130, a star that approximate to the current sun. And then this diagram illustrates the impact of broadband light from the fade young sun on the aqueous photoactivity of the prebiotic polymeric gel. Over right-hand side, we can see that the fade young sun reaching on the non-geothermal pool, where could influence the aqueous, the photoactivity can influence the aqueous prebiotic chemistry just as like photopolymerization or the photodegradations. if we believe that if those monomer solution, just as like alpha hydroxylic acids, have presence in this environment like a non-geothermal pool, but we don't know what kind of, how could it affect on those monomers being present here. When we look at in the left hand side, where it's reaching in the geothermal pool, where there's a fade Young sun's light reaching to the geothermal pool contains of heat energy from the lava water interactions. So this both light energy as well as the heat energy jointly impact those monomer solution as well as all the polymer gel have been present on this environment, but we doesn't know what is the process be going on over here. So my experimental plan is that first, to do the photopolymerization, I expose my monomer solution, especially the alpha hydroxylic acids, under the solar simulator, as well as another to see the photo degradation. I will expose the polymer gel that had been created from the simple wet dry cycle. Once this sample has been exposed, I will run the analysis using the Q-TOF mass spectrum and MR rheology. Besides that, I also see whether this exposure of monomer solution as well as these polymers could affect the formation of the micro droplets. So the take-home message is that my concept to investigate the role of fade young sun in the context of prebiotic chemistry, because especially in the prebiotic polymerization and degradation, because there is a huge gap in those prebiotic chemistry. Thank you.